Have you ever wondered how atoms, the building blocks of all matter, formed from absolute nothingness? Our journey to uncover this mystery begins with the Big Bang, a monumental explosion that sparked the birth of the universe around 13.8 billion years ago. Picture it, a state of unimaginably hot and dense conditions where particles sprang into existence and burst forth in an explosion of energy. In the beginning, these particles were the smallest units of matter known as quarks and gluons. This was a time so intense, so energetic, that these tiny particles moved freely in a state called the quark-gluon plasma. It was a wild, chaotic dance of creation, a time before atoms, before matter as we know it existed. As we descend into this primordial soup of quarks and gluons, we're stepping back to the very first microseconds of our universe. In these first few microseconds, the universe was a quark-gluon plasma, where the tiniest building blocks of matter roamed freely. As the universe expanded, it cooled, setting the stage for the formation of protons and neutrons. The quarks and gluons that had been freely roaming in the early universe now started to come together, thanks to the strong nuclear force. This force, one of the four fundamental forces of nature, is responsible for holding atomic nuclei together. As the universe cooled further, the quarks and gluons began to bind together, forming protons and neutrons. These are the fundamental particles that make up the nuclei of atoms. It was a critical moment in the evolution of the universe, marking the end of the era of quarks and gluons and the beginning of the era of protons and neutrons. This transition ushered in a new phase in the universe's life known as nucleosynthesis. During this phase, protons and neutrons came together to create the first atomic nuclei, setting the stage for the creation of the atoms that make up the universe we see today. With the creation of these atomic nuclei, the universe was primed for the next step in the formation of atoms. Now, with protons, neutrons, and atomic nuclei in place, the universe was ready for the formation of neutral atoms. As the universe continued to expand and cool, the stage was set for the next act in this cosmic drama. At about 370,000 years after the Big Bang, the universe had cooled down sufficiently for electrons to join the party. These tiny particles, with their negative charge, were finally able to combine with positively charged protons, forming the first neutral atoms, predominantly hydrogen. This was a key turning point. With the creation of neutral atoms, light was no longer scattered off free electrons but could travel freely through space. This marked the start of the cosmic era we observe today, an era of stars, galaxies, and planets, including our own. And that's the incredible journey from the Big Bang to the formation of atoms. Remember, every atom in your body and in the universe has a story that began 13.8 billion years ago.